I'm going to teach you the most important problem in the next several minutes. And this is seriously going to liberate you and change your solving skills. I'm going to make a lot of sense and it's going to be deep, but the concept I'm teaching is a little bit advanced. So watch this video more than once if it doesn't connect for the first time, but don't skip till the end. And here, now today's topic is sets and relations, and this is related to MFCS, DMS and DMGT. And here problem number 4 is going to be taught in this video. And see here, problem number 1, 2, 3 are already uploaded in the playlist. Please have a look at it and definitely it will be very, very beneficial. See here, in today's video, if A, B and C are any 3 sets, then the number of elements in A union B union C is equal to, see here, the number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C plus the number of elements in A intersection B intersection C. And this is going to be proved here. See here, as you know that by the principle of inclusion and exclusion, we have the number of elements in A union B is equal to number of elements of A plus number of elements in B minus number of elements in A intersection B. So using this principle of inclusion and exclusion, and I'm going to solve this one. So we need the number of elements in A union B union C. So first of all, I'm going to take that is A union B union C. And now I'm going to write this as the number of elements of, see here, I'm taking this as one bracket, that is A union B. So if I consider this whole thing as one part, that is one element, see here, this is A union B. So if I apply this one, so this will be the number of elements in A plus number of elements in B minus number of elements in A intersection B. So if I apply the principle of inclusion, see here, this will be the number of elements in A plus, see here, the number of elements in B union C. So this is the thing which I am going to consider as a one unit. See here, I am applying in this formula minus A intersection B. So this I am going to write as A intersection B union C. Clear? Got a clarity? And now I am going to apply the distributive law for this. So A is distributed to B as well as C here. In this, I am going to distribute A. So here, this will be the number of elements in A plus number of elements in A union B union C minus. So here, if A is distributed, this will be A intersection B union. This is A intersection C. Clear? And now see here, there is another part here. So if you consider this as a union, that is A union B. So here A union B, again we have to use the principle of inclusion and exclusion. And here also I am going to use the principle of inclusion and exclusion. And see here, this I am going to write as the number of elements in A plus, if I apply the principle here, this will be the number of elements in B plus the number of elements in C minus the number of elements in B intersection C minus. So if I consider this as a two elements, that is A union B. So this can be written as the number of elements of A intersection B plus the number of elements in A intersection C minus the number of elements in A intersection B. This is intersection A intersection C. Clear? And now if I write it here as this one. So this is the number of elements in A plus the number of elements in B plus the number of elements in C. And C, this will be the number of L minus number of elements in B intersection C. And if I send this minus inside, this will be the number of elements in A intersection B. And if I send this minus, clearly this will be minus the number of elements in A intersection C. And this is minus of minus plus. And this is nothing but A intersection B intersection. This is A intersection C. Clear? And therefore, see here, as this is intersection, as the connectives or whole connectives are the intersection, so this is connected by the intersection and A is repeated for 2 times, and therefore this can be written as, and therefore so from where we have started, A union B union C is equal to, see here, this is nothing but the number of elements in A plus here the number of elements in B plus number of elements in C minus the number of elements in B intersection C minus the number of elements in A intersection B minus the number of elements in A intersection C plus the number of elements in A intersection B intersection C. So this is what it is asked to show that. So if I write it appropriate way, then this will be the number of elements in A union B union C can be written as the number of elements in A plus number of elements in B plus number of elements in C minus, if I write it in order, this is minus A intersection B, and after that one B intersection C, the number of elements in C here, B intersection C minus the number of elements in A intersection C plus the number of elements in A intersection B intersection C. And so this is how we have to solve. So this is B, and this is how we have to solve using the principle of inclusion and exclusion. And back to the beginning here. So this is what it is asked to show that, and by using the principle of inclusion and exclusion, so this is the concept which you have to keep it in mind, that is the number of elements of A union B is equal to the number of elements of A plus number of elements in B minus number of elements in A intersection B. So here I have taken this as one bracket, single bracket, and I have constructed this as A union B. So if I apply here, this is A B minus A intersection B. And if I apply the distributive law here, and again in the three cases, if I apply the principle of inclusion and exclusion, and then if I expand here, so I'll be getting the final result as this one, as the number of elements of A union B union C is equal to number of elements of A plus number of elements of B plus number of elements of C minus number of elements of A intersection B minus number of elements of B intersection C minus number of elements of A intersection C plus number of elements of A intersection B intersection C. So this is how we have to solve. This is so simple. So if you keep the concept of principle of inclusion and exclusion, definitely you can solve by your own. And this is the most important question. Definitely it will be asked, and so that you will be getting a good score. If you really like, what to do, please raise your thumb, pass it on to your friends, subscribe to this channel, and look at my next video too, and pass it on to whomever you like the most. That is the greatest help I need from you. Thank you so much for staying till the end.